Well, you know how to add mixed numbers. Now we look at how to subtract mixed numbers. So when we're subtracting, it's actually recommended we line up the mixed numbers vertically. And just, there's not a mathematical reason you have to do it adding horizontally and subtracting vertically. It just seems to be a little easier when we work it that way. So find the least common denominator of the mixed numbers. That part's the same as it was with addition, because for both addition and subtraction, you can only combine fractions if they have the same denominator. So step 3 is also the same. Make equivalent fractions using the least common denominator. So just like I did on the other video, I'm going to go ahead and turn the page over and look at number 1, because as you can tell looking at the whole of the front page, there's a little more complexity to this, but it actually is not as bad as it may appear. So let's flip it over and let's just do those first steps on number 1. So I'm going to tell you what, I'm actually going to go ahead and take care of the common denominator issue, then I'll put them vertically together. I think that'll be a little more efficient. So look at 5 and 4. The least common denominator would be 20. So to make a 5 a 20, I have to multiply it by 4. And whatever I do to the bottom, I have to also do to the top. So I'll have 18. 2 times 4 is 8. 5 times 4 is 20. Minus, here, to make the 4 into a 20, I need to multiply by 5. Whatever I do to the bottom, I'll do to the top as well. So I get 5 times 3 is 15 over 4 times 5 is 20. Okay, now the reason I wanted to go ahead and do this part is I think it'll make it easier to understand what step 4, or I think I call them step 3, A, B, and C. Anyway, the next step, which we'll go back to in a second. Because what you do next depends on whether this second number, the bottom number, is smaller or bigger than the one on top. So just like when you're adding and subtracting like just normal numbers that aren't fractions, if the one below is bigger than the one above, you've got to borrow. But it's a little different how we borrow when we're doing fractions or mixed numbers, so that's where we'll go to the front. So I didn't leave any blanks because I thought it'd be better for me to just talk through it and you just listen and make sure you understand. So if the second numerator, that means the one on the right or the one on the bottom, is greater than the first numerator, then we're going to have to rewrite, this says rename, you can also say rewrite the top mixed number by adding the numerator and the denominator together. We'll make this sum the numerator of the first mixed number. So let me show you what I'm saying, because I know I'm using lots of math vocabulary there, but this is all it means. We're going to change this to be 20 plus 8, which is 28, and rewrite this as 28 over 20. So that's all they were saying to do, is add these two together, 20 plus 8, put that number on top, leave the denominator the same. Oh, sorry, let me get back to that. Okay. So let's go back, see the next direction. So we've done step 3A and 3B. We added the numerator and denominator, made that the new numerator. Then we borrow 1 from the whole number. So the only reason we were able to make this numerator bigger because we're actually borrowing 1 from the 18. So it was 18 and 8/20. Now it's 17 and 28/20. So we borrowed 1 from the 18 and added 20 over 20 to the fraction. Now it's pretty straightforward. We subtract the whole numbers. We subtract the numerators. We keep the denominators the same. We'll get to step 7 when needed, but we'll go ahead and turn back over and subtract the whole numbers, subtract the numerators, keep the denominators the same. Okay, so I'll subtract 17 minus 5 and get 12. 28 minus 15 is 13, and we leave the denominator the same. And that's not an improper fraction, so we are finished. Our answer is 12 and 13 over 20. But we'll go ahead and fill in the front, so we just focus on the back. This step 7 is really the same as it was with adding. If the fraction is improper, then write it as a mixed number and add it to the whole number. So this is the same thing we did when we were adding. Just got to see if we end up with an improper fraction at the end of the game. So when that comes, we'll talk about it. Number 2, already throwing a trick at you, because wait a minute, that's not a mixed number. Well, you're mostly right. 6 is not a mixed number, but we could make it one. And it actually saves us a step because we don't have to worry about having a common denominator, because we can make this denominator whatever we want. Let me show you what I mean. So I know 6 is going to go on top, minus 2 and 1/12 on the bottom. Okay, but I need a fraction up here. The 2 has 1/12 with it, but the 6 has 0/12 with it. And that's the benefit, because if this had been fifths, I could have said 0/5. Or if this had been sevenths, I could say 0/7. So I can put whatever I want on the bottom, because the point is, it has none of them. So we've got it set up, but we notice we run into the same problem we did in number 1, where this numerator, the second one, is bigger than the first numerator. So we will have to do the borrowing method again. That's where we do 12 plus 0 is 12. And we borrow 1 from the 6 and make it a 5. Then we do 5 minus 2 is 3. 12 minus 1 is 11. And we keep the denominator the same. This is not a mixed number, or an improper fraction, sorry. This is not an improper fraction, so we're finished. Okay, number 3. We want to think about the least common denominator. That would be 12 for this one. So we need to multiply this one top and bottom by 2 to make the 6 turn into a 12. So I'm just carrying the whole number 5 there. 5 times 2 is 10. 6 times 2 is 12. This I need to multiply it by 3. 3 times 3 is 9. 4 times 3 is 12. Okay, we don't have to do any borrowing because this time this number is smaller than the one above it, so no borrowing is needed. We can just subtract the whole numbers. 5 minus 3 is 2. Subtract the numerators. 10 minus 9 is 1. And keep the denominators the same. And we get our answer. I don't know about you, but to me it feels a little bit faster with subtraction than with adding, but it could just be my imagination. Okay, let's move on. Number 4. This is similar to one we saw on the adding worksheet or adding notes, because the least common denominator will be 8. So this one is already where it needs to be. We don't have to do any changing to this one. But we do have to double the 4 and the number above it, so it will match. So we have 4 and 5/8 minus 1, and 3 times 2 is 6. 4 times 2 is 8. Okay, so the benefit is we only had to change one fraction to get them to match denominators. The downside is we do have to borrow again on this one because the lower number is bigger than the upper number. We can't say 5 minus 6. So to borrow, we'll say 8 plus 5 is 13. We'll borrow 1 from the 4, making it a 3. And we'll leave the bottom alone. Subtract the whole numbers, 3 minus 1. Subtract the numerators, 13 minus 6. and keep the denominator the same, so you get 2 and 7/8. Okay, number 5. 7 and 5 are our denominators. We need to use 35 as its common denominator. So here we'll multiply the top and bottom by 5. That gives us 8. 2 times 5 is 10. 7 times 5 is 35. Minus, got to multiply this one top and bottom by 7 to make it 35. 4 times 7 is 28. 5 times 7 is 35. So we do, yet again, have to deal with borrowing, because 28 is bigger than 10. So to do that, we say 35 plus 10, which is 45. We borrow 1 from the 8, making it a 7. And we don't change the lower number, we just leave it as is. Subtract the whole number. Actually, let me pause. I'm afraid I'm going too fast. When it's a video, remember, if I'm rushing, you're welcome to pause and catch up with the writing if you need to. 7 minus 5 is 2. 45 minus 28 is 17. And we leave the denominator just as it is. Okay, number 6 is similar to number 2 in that we have just a whole number, not a mixed number. So we have a 5, and we're subtracting from it 4 and 9/11ths. So 5, we'll say, has 0/11ths. And in a shocking turn of events, or wait, same thing all over again, we've got to borrow, because we can't do 0 minus 9. So we do 11 plus 0 is 11. Borrow 1 from the 5. Then leave the second number the same. We subtract the whole numbers. 4 minus 4 is 0. You can write 0 if you want to, but you don't have to. 11 minus 9 is 2, and we keep the denominator the same. So our answer is 2/11ths. Okay, 7's the last one I'll do in this video. The other is similar to wasn't adding. It just gives you more than one to deal with. So it's the same process we've been doing, just have to do it twice, or this one you have to do some adding and some subtracting, but I'll leave that for your own challenge. Hey, cool. One nice thing on 7 is it at least already has a common denominator. But we do have to borrow. I know, shocking. Because 23 is bigger than 13, we can't say 13 minus 23. So we have to borrow. 15 plus 13 is 28. And we have to borrow 1 for the 43. And the bottom, we leave it just as it is. 42 minus 20 is 22. 28 minus 23 is 5. And we leave the denominator the same. Now this is the first time this has happened on this example. We have a fraction that can be reduced because 5 and 15 are both divisible by 5. So this answer isn't wrong, but I'd say it's incomplete because we need to reduce it. So we do 5 divided by 5, which is 1. 15 divided by 5, which is 3. And we get our final answer.